Hello there. This is a quick overview of a smart patch panel solution using generic routers. So what is the problem we are trying to solve here? If you look at IT infrastructure today, we have automated compute, network, applications, power control, except the physical cabling. Every time you need to make a change to the cabling, you still need to go physically and do it. This is more common when you do testing or when you do demonstration to customers, where you want to try different topologies or you want to try connecting an endpoint to different parts of the network being tested. There are existing solutions called as layer 1 or physical layer switches. Unfortunately, they're expensive and it's altogether a different platform to maintain, operate, and support. So what is Magnetron? It's a close cousin of a physical layer or a layer 1 switch. However, it's built using generic routers and controlled using a simple web interface. And the whole web control interface runs on a very tiny Linux machine. Any router from Cisco 7200 all the way up to an ASR 9000 can do the job of being the smart patch panel. Let's look at some of the most desired features which is covered or which is available in Magnetron. Of course, the first one being transparency. When you patch two devices using the switch, the Magnetron switch in the middle is transparent to the end devices. So it's almost like a direct cable. The second one is to relay the link status. Even though the nodes are not directly connected and they are going through the Magnetron switch, if you shut down one end of the link, the other end will go down automatically. Exactly like what happens when they are physically cabled. And there is full end-to-end layer 2 visibility, which means any layer 2 protocol available at one side will be carried to the other side of the link through the switch, which means you see CDP neighbors, LLDP neighbors, spanning tree, and all other L2Ps. This is built using a generic router, so it works on most of Cisco routers running iOS, iOS XR, or even XE. Let's look at an example application of this. I have a test bed with 6 routers, all of them wired to the main Magnetron switch on the left. Now, I can build any dynamic topology on the fly using Magnetron. Well, I can do the same thing with endpoints as well. If I have a PC connected to router 3, I'm doing some testing, then I want to change that connection back to router 4 for some other testing. I can do all this without physically changing any cabling, and I can do this remotely. The other scenario is if I have a bunch of devices and I want to build different test demonstration topologies using the same set of devices instead of building different test beds. Let's have a look at it. Say my first demo needs 4 routers wired like this, and maybe after a while I need a different test bed where I need 3 routers connected in series, and maybe after that I need to build a different test bed altogether, which is test bed 3, using 4 routers wired like this. You can build all these topos on the fly using Magnetron. So it essentially gives you 1:1 physical device to demo topologies, and it's a self-service remote cabling, and we are physically steering the traffic. I have a quick 5-minute demo where I'm going to show you how this works. I have 5 switches, all of them attached to the main central Magnetron switch, and we're going to look at how I'm going to wire all of them together on the fly. That's the user interface for Magnetron switch. Let's look at the route switches first. This is switch number 1. We'll do a basic review of the configuration here. All the interfaces are down at this point in time. And of course, there is no CDP neighbor. Let's go to switch number 5. And we will do the same checks over here. No specific config on the interface. All the interfaces are down. And of course, there is no CDP neighbor. Now let's connect these two switches together. I go and select the source node, which is my switch 1 port 111, and select the destination. Destination is switch 5 port 114. And let's create a patching. While Magnetron works to connect these two switches together, let's look at the console and see what do we see. Here you can see the interface is coming up because it's connected. And you can see the interface is coming up on switch 5 as well. And let's check for CDP neighbors. Here you go. You can see switch 5 as a CDP neighbor in switch 1 via port 111. And if you go to switch 5, you will see switch 1 as its CDP neighbor. So essentially, I just wired both of them together using a few clicks. I have two VLAN interfaces on the switches, the default VLAN 1. I just assigned them IPs just to test. I'm just going to do a quick ping across both the switches to show you that this link does carry traffic. We have even tested it with close to line rate traffic on 128 byte frames on 1 gig. Now let's shut down one end of the link and see what happens. So I'll go to switch number 5 and I'm going to shut down the local port, which is 114. Of course, the local port will go down, but you can see the remote side, which is switch number 1, port 111, is also down. Let's bring the link back up. And the other side comes up as well. And the CDP neighbors reappear. Let's go to the UI and view the same connection. And you can view all the nodes. You can add a node if you want. Or you can even delete one of the existing nodes if you want to. And you can even change the status of the connection without deleting it. Let's bring it down. And you can see the link has gone down. And let me bring the connection back up from the user interface. And the ports are back up. Let's quickly check spanning tree just to verify how rest of the layer 2 protocols are behaving. So you can see switch number 1 is pointing the specific MAC as the spanning tree route, which ideally in this case should be switch number 5 because there is nothing else connected to it. And here you can see switch number 5 is the spanning tree route. So even the STP status information is relayed across. Let's add more links and expand the topology. The process is same. You select the source port and node, and you select the destination node and port, and then just click to add the connection. That's a new connection between switch 1 and switch 4. So here I've taken the second port of switch 1 and connected that to switch 4. And you can see the spanning tree information as well as IP connectivity expanding across to 3 switches now. And you can see all the connections up here in the Magnetron user interface. And I can delete a connection if I don't want to. This permanently removes the connection or patching between 2 devices. And the ports become available for a new connection if needed. And you can see the difference in CDP neighbors after deleting the connection. And the connection table on the UI gets updated as well.